All right, welcome everyone. So I'm going to keep this really short. I'm Toby Grossman, one of your Tux organizers. We're super excited to have our next Sanders Series invited lecture. Anind Dey is here to give a talk. And I'm actually going to introduce Kai Trong to come to the stage and give Anand an introduction.
Great, thank you, Toby. My name is Kai Trong, and I'm from the University of Toronto, and it is my great honor to introduce today's distinguished Sanders Series speaker, who happens to be a good friend, colleague, and former mentor of mine, Dr. Anind Dey. Dr. Dey is currently a professor and director of the Human-Computer Interaction Institute at Carnegie Mellon University. He's going to continue in this role until the end of the year, when he's going to join the University of Washington as their Dean of the School of Information, just the third dean ever there at the School of Information. Anind is a very prolific researcher and, as I mentioned, teacher and mentor. His research lies at the intersection of ubiquitous computing, human-computer interaction, and machine learning. He has published well over hundreds of papers on these topics. And not only does he write many, many papers, but he writes very, very influential papers as well. Just to give you an idea, when we talk about impact as academics, one of the measures that we often look to is citation counts. His top-cited paper is on ContextAware Computing, and it's been referenced well over 5,600 times. His second highest cited paper has only been referenced a mere 5,500 times. So it's got a ways to go, but I think it'll get there. I kid because these numbers are very, very large, and they suggest that Anind has had a very large amount of influence on the area of ubiquitous computing, context-aware computing, and more generally HCI as well. His work focuses in the areas of mobile computing, health, and sustainability, among many, many other topics as well, such as his highly significant work at WIS 2005 on supporting interspecies social awareness, in which he suggests or discusses how to design UIs for both humans and dogs. For humans, he talks about how to design who's, and for dogs, he discusses how to design do's. And in this paper, he talks about challenges with trying to address the constrained or limited canine physiology, as well as the need for doing participatory design, in which you involve dogs in the process to make sure that you design appropriately for them. The main takeaway from this work is that you have to bring lots and lots of dog treats to the process. If it's not clear, this was a joke paper, but as evident in a lot of Anind's work, somehow it makes other people think quite a bit. And this paper itself has been cited about 50 times as well. So it suggests to me that either it's very influential or a lot of researchers just haven't caught on that it's a joke paper. Because of his impact in the field, Anind sits on many editorial boards and has served as the program chair or general chair for many, many conferences, including major ones such as Ubicomp and Chi. In 2015, Anind was inducted into the SIG Chi Academy for his contribution on context-aware computing and adaptive systems. Anind grew up in the Vancouver area. He received a Bachelor's of Applied Science in Computer Engineering at Simon Fraser University in Burnaby, Canada. I was going to say California, that's not right. He then went to Georgia Tech to do graduate studies in aerospace engineering. And after he completed his Master's of Science in Aerospace Engineering, he felt that was too much defense-related work for a Canadian. And then, so he decided to switch over and do computer science, where I had the honor of being his office mate for a couple of years while he's finishing up his graduate studies there. Thank goodness that he decided to switch fields, because otherwise his talk today would be on a completely different topic. And so with that, I'd like to introduce Anind to the stage. Thank you.
I don't know if I can live up to that introduction. Thank you all for coming today. So today I wanted to talk to you about some work that my group has been doing over the past few years. Early on in my career, I focused a lot on context-aware computing, and I'll describe a little bit of what that means. And then I went on sabbatical and I said, okay, well, it's time to figure out what I should be doing next. And I didn't go very far afield from context awareness, this idea of systems that can adapt to the behavior and the situation that things are in. But I started looking at something that was a little bit broader in terms of routines, and so I'll talk a little bit about that. So what is context awareness? So back in the late 80s, early 90s, Xerox PARC, notably Mark Weiser, Roy Want, they came up with this idea of ubiquitous computing and the idea of context-aware computing. And the idea behind it was that rather than have systems that were really static, that didn't adapt to their surroundings at all, what if you had systems that could actually change how they behaved based on who was around, based on what people were doing? Now today we kind of take those for granted. You can see, I don't know how well you can see those, but up at the top you see the PARC board, and you see there's little tabs and pads that they had, and they really were the early predecessors to Surfaces and smartphones and today's modern tablets. So we take a lot of this for granted. There was a huge amount of research in the 90s and the early 2000s on context awareness. This is just a few of my favorite projects from Natalie Jeremijenko's dangling string, which was the string that was attached to the motor in a ceiling right outside a network administrator's office at PARC. And depending on how much network traffic was going, this motor would spin around. So not only did the network administrators have this understanding by looking at their terminal of how much network traffic was going through PARC at the time, but they could hear this motor spinning and see the string spinning to give them this visceral sense of how much traffic was going on. So great projects. You see Hiroshi Ishii's Pinwheel project, which gave you an idea of how much interaction there was, or how much movement or collaboration was occurring in a remote space. All the way down to this project down at the bottom, which is this work from the University of Kent at Canterbury, where they did really what was the precursor to that canine work Kai talked about. And this is human-giraffe interaction, where they were using context-aware tools to try and understand the migratory habits and mating habits of giraffes in Africa. So you start off with all of that really interesting work on how you can take these kinds of technologies and really make them adaptive to different situations. And again, we kind of take it for granted. We all have GPS on our phones. We all have amazing amounts of compute power. And there have been these just amazing trends that have occurred over the past 20, 30 years that have enabled a lot of this. So we see decreases in size from, what one person's joke was for a mobile computer to what the smallest phone I could find on Amazon, which was it would literally fit within the palm of your hand. Tiny Android phone. You see the change in size of computers, from computers that filled rooms to ones that we can now wear on our bodies to ones that we can actually implant in our bodies. So change in certainly the size, change in their cost. We also see change in the sensing technology. This was the very first mobile phone I ever had. My advisor bought it for me in graduate school. It's a Motorola StarTAC phone. It wasn't much of a phone. I mean, you could make phone calls with it. It didn't have any texting capability. It was really pretty primitive. But even then, it had some hidden but available sensing technology in it, right? So it knew, it had access to cellular towers. It knew how far away it was from them and could triangulate and not tell me where it was, but it could certainly figure out which cell tower it should be talking to. You switch to more modern day phones, and they are absolutely chock full of sensing technologies, right? From accelerometers to GPS to magnetometers to barometers, temperature sensors. There's just a lot of sensing technology in any one of these phones that we're all carrying around. And in addition to the sensing power, you have to think about the raw processing power that a mobile phone has. So the iPhone X, which has just been released, at its peak, you can't run this persistently, but at its peak, it generates 350 gigaflops per second, 350 gigaflops of power, of compute power, which is pretty amazing, faster than a supercomputer was only about 5 years ago. So these two trends, both in terms of looking at context-aware computing and getting systems that can adapt to people's behavior and adapt to what's going on in their environment, and the widespread availability of really cheap computing and really powerful computing, made me start thinking about, well, what can we move from if context is mostly about some really primitive things, where somebody is, maybe what device they're using, what's the weather like, how many people are in this room, some fairly primitive sensing notions. How can we start to go up the stack in terms of human understandability and things that make sense from a human perspective? So some people have started looking at human activity. So again, on your mobile phone now, you can figure out whether a phone can figure out automatically, are you running, walking, sitting, standing, biking, lying down? Starting to look at not just where you go, but what are locations. So if you have a Google phone and you use Google Timeline, it makes a pretty good map of every place you've been and what are the meaningful locations, where did you spend significant time at, what are the places you repeat and you go to often enough. and other kinds of sort of higher level behaviors that are interesting. But that still led me to think, okay, we can't focus on that. We did focus on this for a little while. There was a good period in sort of the early 2000s or late 2000s where a lot of groups were focusing on that. But the problem is we kept bumping up against industry. And industry was moving into the space much faster than we could sort of populate it. So I went back to a slide I actually created during my job talk. So this is a talk when I gave at Carnegie Mellon well, a long time ago, when I first applied there. And I thought, what was inspiring me at the time? And context-aware computing has always been about how can I understand human intent, right? The ideal thing is, if I want to understand, if a system should be adapting to what's going on around me, it has to understand how it should adapt. It has to understand what it should do in order to support me as a user. And up until then, we've been using, and at least at this time, 13, 14 years ago, we've been using some really simple primitives as proxies for understanding human intent. We looked at where people were located, what time of day it was, maybe the device that they were interacting with. And those had to be proxies for what people were actually intending to do, what they wanted the system to do. But obviously, those are pretty poor proxies. I could be standing behind with a museum exhibit behind me with a mobile tour guide, and it would assume because of where I'm located that I'm interested in what's behind me. But in fact, if my back's to it, it's actually not a very good proxy for what I'm interested in. It may be interested in the person who's standing across from me. So I started thinking about, and that's one of the joys of going on sabbatical, and you have a little bit more time to think, and really thinking about shifting from people's context to starting to look at routines. And this happened over time. It didn't have to come to me one night. But if we think of routines, if you think of your routine when you wake up in the morning, you probably have a fairly set routine. You get out of bed, you go to the bathroom, you brush your teeth, you get dressed, you take a shower, you get dressed, you have breakfast. Roughly, that's what an average person's routine is. But it will vary over time. And what if we could use people's routines as a resource for innovation? What if we could use people's routines to adapt how applications worked? So around that same time, I came across this really great book called The Daily Routines of Famous Creative People. And this person, another person based on that book, put together this interesting visualization of famous authors, poets, artists, and said, I don't know where this data came from for the book or for the website, but put together this interactive visualization to see how these famous people spent their time. So you can see that Beethoven ate breakfast around 6 o'clock in the morning and then did creative work until about 3 p.m., food and leisure for an hour, then exercise for an hour, back to food and leisure, and then went to sleep for a short period of time. Others, like de Balzac, went to bed at 6 o'clock, but then got up in the middle of the night, and that's when his most creative time was. And so I was kind of fascinated by, well, one, how you could even put this together when these people have not been alive for hundreds of years. But more interesting is, if you had access to this information about the general population, what could you do with it? Or if you had access to this information about any particular individual, would it serve as this resource? And then it reminded me of this paper I read shortly after I was out of grad school, maybe it even been when I was in graduate school. And I'm blanking on the paper, but it's essentially called Unremarkable Computing. It was done by a group at Europark, I believe, or maybe Park in Cambridge, Xerox in Cambridge, where they had studied what people's routines were throughout the day. And I realized, you know what? This idea has been around for a lot longer than I've been thinking about it, but how can we take advantage of technology to actually leverage information about these routines? So, why are routines actually important? Well, from a human perspective, we leverage routines all the time. We leverage routines to be able to offload lots of cognitive load on ourselves, right? I don't have to think about what my morning's going to be like. If I don't have a child jumping into bed with me, I have a fairly standard routine, right? And I can offload that. When my wife takes on the responsibility or the routines for getting the children to a particular activity, I offload that to her, and I don't need to worry about that so much, which is really great. So we leverage routines all the time. We go out of our ways to actually construct routines in order to offload cognitive effort off of ourselves. But when there's a deviation, so I'm actually living across the country, 2,500 miles from the rest of my family right now, but when there is a deviation, such as when my family moved across the country, or even I'm just out of town for a few days, that causes deviations. All the things that I'm responsible for, my wife has to take care of. And all this information I have about how to construct those routines, how to enact those routines, is kind of lost because they're so natural to me that I don't even think to convey to her, oh, do this, this, and this, because they're just so natural to me. So these points, not only are routines, I think, in and of themselves really interesting, but when you can identify or even predict when a deviation might occur, those are opportunities to do this kind of adaptation that I think is really interesting, and I spent most of my career working on. So I do think there's lots of interesting things here. I will say that hopefully you will see this as beyond pattern matching. There is a lot of pattern matching in what I'm going to talk about, but I think some of the technologies that we can start to bring to bear are beyond what we would think of as traditional machine learning and traditional pattern matching. So there's lots of ways that we can use, I think we can use this technology to impact everyday life, and I'm going to start talking to you about a few of those. So as I said before, huge changes in mobile phone technology over the last 20 years, and that's really where we started with a mobile phone, because people already carry them, and then this amazing resource and source of information, from virtual information, the applications people are using, the various information sources they're looking at, social information, not only who are they interacting with on their phone, but who are they interacting around while they're carrying the phone, and then of course all the physical sensors. And when I first started getting into mobile computing, my goal was to really build, and I still would like to build this, but I think it's going to take me far longer than I have to actually do this, but really build a phone infrastructure that from the moment I pick it up from the store, the moment I stick the SIM card in and I charge it up, it starts learning my behavior over a really long period of time. And then in 1.5, 2 years, when I move from this phone to my next phone, it takes everything I have, everything the system's learned about me, and is able to leverage that. Now, I'm still reasonably young, older than I think most of the people in this room, but I'm still reasonably young, and so I haven't hit against the health issues that I'm expecting to hit when I'm another 10 years older, 10 to 20 years older. And boy, I wish that I would have access to this amazing resource of what my life was like when I'm older. So I could see, what is my gait now versus what it is 10 years later? Would that be useful for someone who's trying to do diagnostics on my hurt knee? Would information about my diet, when I ate, when I went to bed, would any of that actually be useful from a health perspective in 20 years? So I still would like to do this, but I think there's some more core and more interesting challenges to solve first. So the first thing we did was build a basic smartphone infrastructure so we can collect lots of information, do all sorts of modeling, sensing on the phone, model it, analyze it all in as power and privacy sensitive a way, and then be able to provide services back to applications. And since then, I've branched out from just using mobile phones and now really looking at, if you had IoT environments, Internet of Things environments, embedded devices, wearable devices, how could you take that same infrastructure and leverage it for all of those? So some of the challenges over the last 5 years that my group has been focusing on is really trying to understand, getting back to this idea of how do we understand human intent, and is that even possible? Especially through, I will argue again, fairly poor proxies, right? My mobile phone is a poor proxy for my intent, but it's certainly better than just knowing where I am and what time it is. So we've been looking at how to leverage opportunistic sensing, so again, devices in my environment, something I'm carrying around, something I'm wearing to capture behavior, looking at how to create novel algorithms for extracting that routine information and even predicting when someone's going to enact a behavior in a routine way versus a deviation. And then how to do that, how to build really large systems that will support modeling of this behavior so that you can solve some interesting problems. So please don't read this slide. This is more just a pointer for me, but we've been working, like I said, for the last 5 years ago, I guess now 7 years for a lot of these papers, but in a bunch of different areas, from healthcare to sustainability to mobile phone usage, really showing how, if you can leverage simple routines at this point to more complex routines now, how you can leverage it for some interesting things. All right, so let me jump into one project in particular, and I'll jump around between a few different projects, but this is the project I think that really got me started down the path of routines. This is the PhD work of my former student Matthew Lee, who's now at FXPAL, and his system is called DwellSense. And essentially think of it as IoT for understanding aging. So you might have a set of cognitive tasks that make up activities of daily living, things that an elder should be able, any of us should be able to perform independently in order to maintain and live a high quality of life. And that's everything from taking medicine, to answering the phone, to making coffee, to balancing your checkbook. So Matthew looked at a lot of these activities and said, which of these could we actually sense in a reasonable way? Now, Matt has a cognitive science background. My electrical engineering and aerospace engineering was a long time ago, so we really had to go easy on the sensing, so we took some of the easier tasks. So in particular, we implemented a sensitive pillbox, a sensor-based pillbox. So you can see there's two $3 pillboxes that are glued back to back. Sensing's on all the batteries and all the junk is on one side of it. It doesn't look particularly pretty. And then on the other side, it looks mostly like a normal pillbox. And the thing the pillbox could do is it could tell you when you had opened a door, when you had flipped it over, when somebody had stuck their finger in to get pills, whether there were still pills in each of the doors. He instrumented phones. This was really simple. This is an off-the-shelf DTMF decoder, and it was just to look at calls coming in and calls going out. And then he instrumented the coffee maker, which was probably our biggest challenge because neither of us knew what to do with the liquids. But here it was measuring whether you'd put a filter in, whether you had put coffee grounds in, whether you'd put water in, whether the carafe was in there. It was measuring a lot of these different things. And the main thing that I wanted to point out here is why routines are important. Well, so my parents are elderly. They need more care now than they can provide care, say, for their grandchildren at this point. And when I go to their house, I can tell that they've taken that it's Tuesday. I can tell that they've taken their Tuesday medicine because when I go there, I can see this clear box and I can see the Tuesday medicine's gone. What I can't tell is how many mistakes they made on the way to a successful outcome, right? So as people get older, they're still able to, obviously we know this, people are still able to perform the tasks that they need to. If they wanted to make a cup of coffee, they would still make a cup of coffee. But what I can't see, I get that single snapshot. I can't see the whole pattern of activities that occurred up until that point. And that is that pattern of activities, that set of activities that occurred, that's where I think the interesting information is. So they could be mistaking that, getting confused about, oh, I think it's Monday today, so they're going to open the Monday box, and then maybe they'll look at the Sunday box and realize, no, they've already taken that medicine, oh, it's got to be Tuesday. But I miss all of that because I only get that single snapshot. I'm going to skip some of this. So this is a sample deployment that we did. So we deployed it to about 30 households in Pittsburgh. And you can see a pretty messy environment. This woman's apartment was pretty, well, it was stuff all over the place. She was a crafter. So you can see her glue and supplies were here. Her pillbox was over here. Our hidden laptop was hidden behind the TV. But a pretty messy environment. And then we provided each person with a display in the environment. And this display was very simple. It didn't remind you to do anything. It just reflected what you had done in the past. So here you can see the person took their morning medicine on time, which was for them about 6 o'clock in the morning, but that they were confused about what day of the week it was. They're here, they opened Sunday, Monday, and then they correctly opened the Tuesday box. The afternoon medicine they just forgot to take, and so they're given a score over here on correctness and timeliness. And then for the calls, we had a lot of aspirations about what to do with phone calls, and we simplified it to just be how many missed calls, how many missed dials did you make? So if you're dialing a number, like how many times do you start, stop, dial, try and dial the same number over again? How many times do you do that before you actually get through? So this person had made 8 calls, 2 of them were missed dials. And then the task of making coffee, and so what they did here was they actually repeated putting the carafe in a couple of times because they're having difficulty. So they got the score, and they got this. They had this in their homes for quite a while, and we wanted to see how did it impact their long-term behavior. Well, for some of our participants, they got this display, and other participants, we just collected the data about their behaviors, and we showed it to them about 4 months later. And so, let me turn this audio off. So I don't know how well you can read this with this font, but it says, the research says, before, did you think you were doing it regularly? Did you think you were taking your medicine on time? And so Pearl, our subject, said, yeah, absolutely. I would have bet my life that I didn't miss any days, because that's one of those things about getting old. You actually physically say, no, that couldn't be. I know I took it today, and you didn't. I hate to know that. I hate to acknowledge that, because it's just another one of those things that you don't want happening. But this surely does show what you're doing wrong. So here's another case where now I'm going to show you what happened when we had the display in place. So here's a couple of months of one subject up here on the top. So we have months going along the horizontal axis, and then time of day along the vertical axis. So this is midnight to midnight at the top. Sorry, midnight of one day to midnight of the next day on the bottom. So you can see here that before we put our visualization in, just when we were sensing information, that the morning medication was taken all over the place. There were a number of mistakes being made, red dots where they didn't take their medicine, and yellow where they took it very late. And then the evening medication tended to be on time for this person. For this person here, they only had morning medication, and you can see that there were lots of mistakes being made, either taking it late or not taking it at all. And then once the displays got put in, you can see a lot of regularity in the behavior. So we know that having that display that didn't remind them what to do, but reflected what happened the day before, acted as this mediating influence on how they took their medicine in this case. And this person still continued to make mistakes, and there's a couple of mistakes here and over here, but on the whole, they were able to take their medicine well. So that was really interesting to us, and we think that this kind of work can lead to lead to automated assessment of independence. Particularly to assist a cognitive or physical therapist, occupational therapist. I mean, one of the challenges in doing this work in the United States is that the average elder is only seeing their clinician or even seeing an occupational therapist once every 3 months at best, to once every 6 months, to once a year even. And so if we can provide information of, hey, these are the individuals you need to spend more time with, or go visit, prioritize these during your visit schedule, that could be really interesting. I want to point out this one patient that we dealt with that actually passed away during our study, because this is where our idea of, well, what if we could study routines? And this is going to be a really obvious example and a sad example at the same time. So here we were studying this gentleman, and he was doing pretty well. You can see he was taking his medicine late a few times here, and in the evening he would take his medicine. He was getting, he had started out really well, and then he started making mistakes, but nothing significant. He was never forgetting to take his medicine. He had a bad fall in January, and he was hospitalized. He broke his hip, hospitalized, and he passed away. Not an uncommon outcome for an elderly person who breaks their hip. We went back and looked at the data, because we were not looking at any of this data in real time at this point. We were just sort of collecting it and then trying to analyze it. And what we saw is that, well, actually, there was some significant change before this fall. And in fact, what's not shown on here is in mid-December, right around here, he had a visit with his physician, his primary care physician, and this physician asked the typical question, are you taking your medicine, are you feeling well? And the answer is always, yes, I'm taking my medicine, yes, I'm doing well. Because for most of the elders that we've been dealing with, they don't want to admit that they're not doing well. They don't want to have to be a behavior forced upon them. But it turns out he wasn't. He had, you can see, he took still the same number of late medicine, but certainly a lot of medicine that was not taken both in the morning and the evening. Now, again, this is a very obvious case where if you start to see a change, a deviation from if this is the baseline behavior, you can start to have to intervene, and hopefully that's the case. But that got us really started on looking at this idea of routines. So then we went back and said, okay, well, we can look at these patterns, but is there something more that we can do from an algorithmic standpoint? Because we can collect massive amounts of data about individuals. Excuse me. We can collect massive amounts of data from individuals, but can we actually come up with a new way of processing that? Because otherwise, we're just throwing data into a black box, visualizing it, or coming out with some predictive outcome, and that's not particularly interesting if the goal is, one, to be able to reflect on those behaviors, and two, be able to instantiate interventions for behaviors, good or bad. And particularly on the good side, if you can understand a set of people who are performing a behavior really well, what could you learn from how they're performing those behaviors, and then apply them to those who may not be performing well? So we looked at some past work that my group had done, and this is actually work done by Brian Ziebart, who's my very first PhD student at Carnegie Mellon, who's now a professor at the University of Illinois. And he was looking at location, and looking at people's routines around location, although I don't think I appreciated that framing when we were doing the work at the time. So really simple, this is 2 places in Pittsburgh. If your goal is to prioritize, minimize the amount of time you're driving in a car between these 2 places, this is the route you're going to get. And if instead you want to travel the fewest number of miles or kilometers, this is the route you'd get. So not surprising, depending on how you prioritize, you get a different route. Now, there's other things that we care about just besides time and distance traveled. We care about cost. We care about how much congestion we're going to face. This is not a problem I face in Pittsburgh, but I understand it's one that people here in Toronto face. You have to have routes that actually make you feel comfortable to drive. This was certainly a common image growing up in Western Canada that I faced when I was a young driver. There were lots of places I felt very uncomfortable driving because of all the snow on the road. And it's not too hard to imagine that you can actually build a unique fingerprint for individuals that describes how they typically drive, what their preferences are for driving. Right? That's a unique thing. I mean, there's lots of unique things about every single one of us, and you can use any of those to be able to identify or uniquely identify different people. But here we want to talk about driving behaviors and driving preferences. So we did the first thing that a really naive HCI person would do. We tried to build an interface and said, okay, drivers, try and use this interface to say what your preferences are every time you get in the car. Obviously, this is totally stupid. Nobody should ever do this. Because nobody wants to set that, right? Having somebody specify how they want to drive every time you get in the car, it's not even something we think about. We just get in the car. We may listen for traffic information. We may listen to the weather, but then we just make decisions, right? We don't actually consciously think about, okay, I'm going to go here and I'm going to take a left turn here. We don't think about that. And that's one of the nice things about driving a car. There's often times, I'm sure when you've been in a car, when you get to your destination and you don't even remember being doing the driving at all. And that's kind of the essence of what we're going for. So rather than having users specify their preferences and turn all these little knobs, can instead we learn their preferences from their behaviors. So if you think about a traditional navigation system, you have a starting point and an ending point, and it's a road network, so there's features of the road that talk about cost or distance, and it's looking for the path that you would take to get from one end to another at the lowest cost. That's how all traditional route recommendation systems work. Instead, what we wanted to do is, what if we instead observed, we didn't tell people how to drive, but we had just observed that this is the path that they took. And we knew that these were all of these other road edges were edges that they could have taken if they'd wanted. But for some reason, in that situation, they decided to take this. And if you observe a person driving for enough time, in our case, it was about 2 weeks that you need to observe somebody for, you can start to learn what their preferences are over time. And that's really the crux of the approach that we're taking. And I'm not going to go into the math, actually. I have a bunch of math stuff in here. I'm going to skip past it. But it's this idea of maximum entropy inverse planning. I want to give you the gist of it. So the idea here is that much like nature likes to spread entropy as much as possible. So if I were to, I'm not going to, but if I were to drop this bottle of water on the ground, the water would spread everywhere as much as it possibly could with the constraints of gravity and viscosity, right? And there's literally, no, I shouldn't say literally, almost realistically no chance the water's all going to collect back up and go back in the bottle by itself, right? The probability of that is so low, and because nature wants to spread entropy. So similarly, if we go back to this graph, we can say that if this were a true system in nature and there were no forces acting upon it, then any path along from the start to the end would be equally likely. But because there are forces acting on it, it's the forces that are acting on it, the information you can understand about this person and what they're thinking, that are causing them to take a particular path. And if you understand what those forces are and how the person responds to those forces, then you can build this pattern of them. And that's the basic idea of how we've been doing a lot of our work over the last few years. And like I said, I'm going to skip past all this math. Okay. Sorry, there's a lot. Okay. All right, so what can you do with it, right? I think that's most interesting. So now that you have these patterns of behaviors, what can you start to do with it? Well, the first one we wanted to come up with, and the thing that was driving us was, well, when I'm driving from here, say, to the airport, and say my mom's got a car right beside me, and she wants to drive to the airport, we should get different routes. Just because we're both using Google Maps doesn't mean we should both get the same route. She should get a route that matches the way she prefers to drive, and I should get a route that matches the way I like to drive. Similarly, we can do things with unanticipated hazard warnings. This is one I actually use. So I don't look at my phone when I drive to campus. I live actually very close to campus. On the few occasions when I drive, I don't look at my navigation system. But what happens is the system's constantly working in the background. And based on the turns I'm making, it's making a prediction, one, of my destination, based on my patterns that it's seen over time, and two, trying to predict the route that I'm going to take to that destination. And then over time, not very much time, it can do a really good job at making those predictions. And what it can do then is it says, okay, I see you're trying to go over here, and this is the route you're going to take. Well, there's an accident up ahead on your route that I think you're going to take. So I'm going to suggest, it interrupts me, my phone buzzes, it interrupts me and says, I think you should take this other route because there's an accident on your route. And that's really effective because it's providing me value even though I'm not actually interacting with the application. So there was a bunch of things that we did with it. We tested this out with taxi drivers and collecting a lot of information in Pittsburgh, but I'm going to skip all that because I think it's less interesting. Okay, so fast forward a few years, and we said, okay, we have this technique that can collect information about how people behave, and now we're looking for good cases, good applications where we can actually apply this work. So we started looking at aggressive driving. And in the US, aggressive driving accounts for about 1,500 deaths per year and about $40 billion due to car crashes. And so it didn't really start with Nikola, but a U of T alum, undergraduate and master's alum, Nikola Banovich, has been working with me. He was a student of Kai's before he came to Carnegie Mellon. He's been working with me and my wife. He started looking at this and saying, why can't we start to analyze how people are driving, and can we identify, can we use patterns of behavior to better classify, this is an aggressive driver, this is a non-aggressive driver. So the gist is, if you analyze enough patterns of these two groups of people, you can see patterns of behavior that really uniquely identify this group, or these members of this group as being aggressive drivers, and behaviors that classify or can be correlated around non-aggressive driving. So now you have a new driver or a new drive that somebody's going on, and by the behaviors, you can place them in one of the other categories. So Nicola's been looking particularly at interventions. And so this is one of the interventions he's come up with. This is not by anywhere near the final version, and it's not even clear when you would show this to an aggressive driver. One thing we've learned from doing this work is aggressive drivers don't like to be told that they're aggressive drivers. In fact, they respond pretty angrily about it. Surprise, surprise. So I don't know when you'd show this to an aggressive driver, but here we have, I'll just start this. So here's just somebody who's speeding through an intersection. And what you can see here in this white car is what the aggressive driver did, and then it'll be replayed, and superimposed upon it will be the non-aggressive driver in gray. So that's the aggressive driver speeding through the intersection. I'm sorry, the aggressive driver is still in the gray, and now the non-aggressive driver is in the white. So you can see the non-aggressive driver did the right thing, they just went more slowly through the intersection. Here you see someone taking a sharp left turn, braking, rushing out, hard brake right there, and then completing a left-hand turn. And then the non-aggressive driver, doing a much smoother turn and actually getting through the intersection much more quickly. Like I said, I don't know when the right time to show this to somebody is. We are working with specialists in a lot of these domains that I'm going to talk about. We are working with clinical specialists and driving specialists who are helping us figure out when are the appropriate times to intervene. Obviously, a lot of the literature says intervene as quickly as possible to the event that you want to do the intervention for, but not while somebody's driving their car, obviously, and not when they're sitting at the next stoplight. They don't take kindly to that intervention. One of the challenges that we've been facing now is actually how do we support visualization and trying to understand these routines over time? Because having a system that understands it is one thing, but can we actually build a visualization? And this is really complex, I'm not even going to get into this, but can you build a visualization that can actually help an expert, so a driving expert or a clinical expert, understand behaviors, interact with a system to be able to say, well, if I intervened here, what would I expect the outcome to be? And if you have enough data collected about people's behaviors, you can actually start to simulate these things. And so we played around with a few different visualizations, and this is still definitely work in progress. This is one of our newer systems that we've been working on, particularly for a clinical domain, and I'll talk about it in a second. But we've been looking at clinical domains, a number of different clinical domains, from cancer readmissions, which is the project I'll do a little bit of a dive into, to binge drinking, to depression, to a lot of mental health work. And here we can do things like, we can see that how different patients essentially have different sets of behaviors. So they might start out demographically and clinically as very similar, but over time, they might have the same intervention here, they might take the same action here, but at some time they separate and have very different outcomes at the end. And there's a gross simplification of the cancer work that we're looking at. But the goal here is to see whether we can not only have our system extract those routines and reason about them, but help clinicians actually trying to make sense of it, to ideally identify what intervention should be applied to a particular clinical population or clinical patient, and help them, I guess in an ideal world, be able to come up with new interventions. So one of the projects that we've been working on recently has been in hospital readmissions. So we've been working with a pancreatic cancer population in the city of Pittsburgh, and the goal is to see if we can predict the likelihood that they're going to be readmitted into the hospital within 30 days. So again, a very American standpoint. The Affordable Care Act in the United States, what's commonly known as Obamacare, it has penalties that hospitals have to pay. They get less money effectively if they have readmissions back into their hospital be above a certain level. So the more people they can discharge from their hospital and get to stay at home and be healthy at home, rather than come back to the hospital, they actually make more money. It hurts them if they don't. So there's been a lot of emphasis on studying this 30-day readmission. So it's in the hospital's and insurers' best interest to try and keep people out of the hospital, ideally for as long as possible, but financially speaking, at least for 30 days post-discharge. But it turns out for surgery patients across the board, and this is a pretty wide range of surgery patients, the readmissions rates are pretty high, 13 to 37%. Readmissions cost Medicare, the sort of standardized Medicare for medical care for elders in the United States and the disadvantaged in the United States, cost them $26 billion a year, of which $17 billion, so about 2/3 of it is or 3/4 of it is considered to be preventable costs. So where do those costs, what's the impact of that cost? Well, obviously, we pay for that in some perspective. The insurers are taking on some brunt of it, but in the end, consumers are paying for that. It does result in a lot of family stress and individual clinical stress or patient stress because you're going home, you think you're doing well, and then you have to go back in. And unfortunately, readmissions, high readmissions is also tied to increased mortality rates. So when somebody's in the hospital for, say, pancreatic cancer, they're being monitored. I mean, as you would imagine, they're being completely monitored. There's tons of data being collected about them. They have things attached to their finger, to their body. Everything that comes out of them is being measured. Everything that goes into them is being measured. So amazing amounts of behavioral tracking while they're in the hospital. And it all goes locked up into this electronic medical record. As soon as they go home, they have no information. Right? There's no information except what the patient self-reports, which is, for the most part, fairly unreliable. And then when somebody gets readmitted, then they start the collection back up again, but there's no information of what's happening in the middle. So can we leverage this remote passive monitoring of these rhythms, of these patterns of behavior, to try and predict someone's risk of readmissions? And I'm going to show you very preliminary results because we're nowhere close to the end of this study. But the idea here is that at pre-op, which is about preoperative visit, which is about 2 weeks before someone comes in for their surgery, they make one last visit to their doctor, and they're given a Fitbit. In this case, we're using a Fitbit Charge HR. It collects heart rate and movement, sedentary behaviors, and sleep information. And then we give them a mobile phone that we've instrumented with the software I showed earlier. So they're collecting data for 2 weeks, the 2 weeks that they're at home, hopefully being quite comfortable. Then they come in for surgery. We take off the device. They're not carrying the phone around, obviously, until they move from the intensive care unit into a recovery ward. And they're in the recovery ward for, it varies, but anywhere from about a week to 2.5 weeks is on average that range. And so that entire time, we're still tracking. We know we have all the clinical data. We have access to everything that's going in the electronic medical records, but we also have access to all of the sensor data that we're collecting. Then at some point they get discharged, and then we're following these patients up to 60 days past discharge, and we're trying to see when have they been readmitted. The interesting thing, again, we have a very small enrollment at this point. We have 42 patients enrolled. About 38 of them have now made it through the entire study. And you can see that at the 30-day mark, a quarter of our patients were readmitted into the hospital, and at the 60-day mark, a third of our patients were readmitted into the hospital. So we have some preliminary data here that we think is interesting, but we're not quite sure how to make sense of it. And this is the kind of thing that somebody can have just thrown into their favorite machine learning model and gotten out. But we're hoping, and again, like I said, this is very early work for us, but we're trying to understand how we can leverage this information and leverage routines in particular so that we can understand what's happening on the other side, what's happening in terms of readmissions or risk of readmissions. So that's everything from, so my clinical partner really puts a lot of belief in sedentary behavior. So the more you're sitting around, the more she calls them sedentary bouts, so the more time that you're not active. She doesn't even care about how many steps you're taking, but she wants to know for what periods of time have you been sedentary, and she thinks those are clinically interesting. So she's been focused a lot around those. And so here you can see, I don't know how well you can see that, but in blue we have the patients that were, this is a subset of the patients. You can see in blue we have the patients that were not readmitted, and in pink we have the patients that were readmitted. And along the x-axis, we have location entropy. So how much time are you spending in many different locations? How is that entropy spread around different locations? And you can see in general, the readmitted patients are spending their time in many more places, just a short week past discharge, in 1 to 2 weeks past discharge here. And then on the vertical axis, you can see how active patients are. And so you can see that while you have a lot of inactive patients over here, you also have a lot of inactive patients for the patients that were readmitted. Now, the difference is that as time goes by, the readmitted patients get more active, which would make sense because they tend to be healthier, but the non-readmitted patients, the readmitted patients don't improve over time. So we're starting to analyze this data. We think it's really promising, and we're just now at the point where we think we've collected enough data that we can start to mine it for different kinds of routines. So our current work has really been focused along trying to identify new application domains for this work, and we've been applying it from everything from education, so interactive tutoring systems, how does a person interact with, say, an adaptive educational system online, to the clinical domain, to driving, and a bunch of others. We've been looking at how to build visualizations to help both us understand these routines, because many of them are more complex than most data I've ever dealt with, and then really work with domain experts to help them understand and explain different kinds of behaviors. And then, I think what's most exciting is I have a new PhD student, Julian Ramos, who is looking at, if you understand someone's behavior over time, can you actually start to use that to optimize interventions? And obviously that kind of makes sense. If you go to a doctor and the doctor says, well, Anind, I know you're walking like 3,000 steps a day right now. I'm not going to tell you tomorrow start walking 10,000 steps per day. That's not reasonable. But what happens if you have 50 interventions that you could apply? Could you actually start to look at someone's routines, really look at someone's routines over time, and optimize, algorithmically optimize which intervention would most likely work for this individual given their patterns over time? And not just optimize which one to pick, but even how to generate that intervention for the person so that they're more likely to take it up. So some of the work that we've been doing, and this is my last few slides here, some of the work that we've been doing recently has started to look at this notion of intervention. So I had a colleague, a clinical psychologist at the University of Pittsburgh, come knock on my door one day and said, hey, I heard you guys are doing some really interesting things with mobile sensing, phone-based sensing. He studies substance abuse, and he studies binge drinking in particular. Now, Carnegie Mellon doesn't have a lot of it. It's a very small, non-sports school in the United States. University of Pittsburgh's a different kind. This is being recorded, right? So I should be polite. It's a different kind of school. It's got fraternities. It's got sports. It's a big-time sports school. So there are different kinds of activities that happen at University of Pittsburgh than Carnegie Mellon. We can redact this later, right? Okay. I apologize to my colleagues at the University of Pittsburgh if they see this. But it's true. If you look at the binge drinking rates at the two universities, there's a big difference. So he said, can you tell when somebody's drinking from their phone? I said, no. There's no way I can do that. I mean, how would I even start to do that? And he said, well, at least take a little while and think about it. So I went out with my group, and we went to a bar, and we started watching people drink, and we said, no, there's still no way when someone's phone is in their pocket, even if it's in their hand, how can we tell that they're drinking? And so I went back to him, and he said, no, think about it one more time. Just really, this is such an important problem. There's got to be something we can detect. I said, okay, well, let us collect some data. So we collected some data on ourselves and others as we drank. And I should classify what binge drinking is. Binge drinking it depends on body mass index, but in broad strokes, binge drinking is 5 drinks for a male over a course of 2 hours, and 4 drinks for a female over the course of 2 hours. And binge drinking, of course, is associated with lots of horrible behavior, people getting behind the wheel of a car, causing accidents, making really bad life choices. Sexual assaults often spring on college campuses as a result of over-drinking. And it can have long-term health impacts, negative health impacts. So we collected this data, and it turns out we can't predict anything right now, but we can detect when a college student is lightly drinking, less than binge drinking, and binge drinking in pseudo-real time. And within about 20 minutes of that transition from not drinking to drinking, we can detect that. And within 20 minutes of lightly drinking to binge drinking, we can detect that. And if you think about it much more than we did, and in retrospect, all of this seems obvious, but when you start collecting this data and you look at people's patterns and the routines over time, you can see things that change. You can see that how they text changes dramatically, right? The spelling mistakes that they make, the auto-corrections that have to kick in, the time between key presses totally changes. If you look at, gait was not particularly useful, so how people are walking. Turns out that most of these students that we were working with, and I should say, most of them were wearing these, we call them the Lindsay Lohan bracelets, but they're the GPS trackers that they tell how much alcohol you're drinking because of they have chemical sensors on them to tell how much alcohol is extruding through your skin. It's not a sweat detector, but as the chemicals extrude through your body, it can detect those. So that was our ground truth. So we knew how much they were drinking at any given time. And so gait wasn't useful in particular, that's where I was going. So gait wasn't useful because when they started drinking really heavily, they would stop moving. They would sit there. They'd be sitting because we observed them, right? They're in a fraternity house, they're in a bar, and they would just sit there and it'd be like this motion. They'd be talking, they'd still be, but they weren't moving very much. So it was useful to tell us when they started drinking because you could start to measure changes in gait, but when they got to binge drinking, gait was pretty useless. But we understood first by looking at these patterns of behavior, those that were binge drinking, those that were not binge drinking, it gave us more insight to pull out how to be able to differentiate between these different classes. So we're about 95%, 96% accurate at detecting not drinking, drinking, and binge drinking behavior, again, within about 20 minutes of the episode. Something I thought a few years ago would have been absolutely impossible. We're now trying to predict in advance, say that somebody is early afternoon now, that somebody this evening is going to binge drink late tonight. I'm very skeptical about whether we can do that, but I've clearly been proven wrong already, so we're going to try that out. The last project I want to, again, it's really early. We only have a data set collected at this point, but it's something that I've been thinking about for quite a while. There was this great article in the New York Times, Sunday magazine, probably about 5 years ago now. It was, I think there was about an art exhibit on a major college campus in the US called 1,000 Backpacks, and it was essentially to represent the number of college suicides that occur in campuses in the US every year. Due to mental health, depression episodes. So I became really interested in this project. I partnered up with some other colleagues around the country, around the US, that were interested in this. And we've collectively been doing work where we're collecting large amounts of data from lots of students. So at Carnegie Mellon Small University, we collected really invasively tons of data from 200 freshmen from December to May. So just before spring semester started, all the way to the end of spring semester, and now we're replicating the study again this spring at Carnegie Mellon. We chose freshmen because they tend to be at greater risk at different points because they tend to move far away from home, their whole social network is gone, they have to recreate their social network, and life is very different in college for them compared to someone who's in their second or third year. And we're right now at the point where we're trying to detect. So we collected depression information before and after. They were given a Fitbit as well. They have the phone. So we have this massive amounts of data about every application they used on their phone. We have information about what they typed on their phone, really, really kind of invasive information, including audio information. And we're now trying to mine that data, try and pull out these behaviors that will help us predict, in retrospect, someone who was not showing any signs of depression before the study, and according to this instrument that we use, a well-known clinical instrument, that they were showing signs of depression at the end of the study. Can we predict that? And how early in the semester could we have predicted that? So some really, again, early results show us that. And I can't explain this. I don't have any explanation for this. But the amount of sleep that students get in their very first week when they return back to campus seems to be very predictive, very well correlated with their depressive state, their change in depressive state at the end of the semester. No explanation for why that's reasonable. So right now we've been sort of picking and choosing various features that we think are interesting, sort of a more traditional machine learning approach, but our goal is to apply this routine-based work. Right. So again, I'll repeat that I think the biggest challenge we have to face in this area is really still getting at human intent. It won't happen in my lifetime, and I don't know if we're going to all walk around with neuromorphological displays, sensors on our heads, but it is something I think that would be really valuable to have systems that can predict what it is that we're trying to do, that can actually be assistive and not just automate things for us. So I'll end there. Plenty of people to thank, and I'm happy to take any questions.
Hello? Yeah, if anyone is...
Just put your hand up and we'll pass them around.
Yeah, I think. Hello? Yeah, it's on. It's on. We have questions? Yeah, just making sure.
Oh.
Yeah. Yeah,
Okay, I'll start with the first question, and please think of questions. We're really lucky to have a speaker like Anind here, so this is your opportunity to interact with them. I guess you kind of hinted at it right at the end of this issue of privacy, and it seems like you can do incredible stuff.
Yeah.
And the more you instrument our environment or instrument ourselves, the more more capabilities you or companies that are doing things like this will have for some serious social good, right? Which you obviously indicated. So where's your opinion on like how far we'll go, and like how much do you think society is going to bend to the requirements for these, you know, social good causes?
Yeah, and I think a couple of the projects we talked about, I think, are good examples of where I don't think people are going to bend. So if you're a binge drinker, you don't want to be tracked for your drinking behavior. If you're an aggressive driver, you don't want to be tracked for your aggressive driving behavior. We got our subjects for the aggressive driving study, we got our subjects from people who were forced to take driving rehabilitation, essentially, because they had sped too many times, they'd gotten into too many accidents, they had been diagnosed as aggressive drivers and had to participate in this kind of study. For our binge drinkers, we recruited them from the emergency room, people who had self-reported alcohol abuse, and they were in the emergency room for alcohol abuse. In other places, we have done work where we've worked with people who've been under court-ordered rehabilitation because there's an absolute need to do it. But I do think that these are edge cases. I mean, most of us are not going to jail in order for us to take on these new behaviors. We've tended to focus on things where I think it's kind of obvious that we should be sensing these, but I do have this huge worry that the technology that we're developing can be used for all sorts of things. So, I mean, really simply, knowing when somebody is abusing alcohol, if that was ever broadcast to anybody, even outside of a very, very local social network, could be, amazingly bad things could happen. So I am hugely concerned about this. I don't have any great answers on what the right way to protect this data is. I do think that there's many times where the intervention should just go to the individual, so hopefully it never leaves the comfort of their own device, assuming that device can't be hacked. But there are some cases, like in the binge drinking case, the natural intervention is tell their local support network, but if that information gets out, it could be really bad.
Hi, I have a question up here on the steps.
Yes.
Hello. Particularly when it comes to monitoring and sensing health-related, like your medication adherence example, do you find that you're moving into a territory of like moral obligation in terms of how to intervene, or like you were just saying, how much that information is shared? Like in that particular instance, if that patient's physician or family had been aware of the pattern, could something have been done?
Yeah, that one still keeps me up at night. When we do that kind of work, our IRB explicitly says, you need to tell us if you're looking at the data, and we prefer you don't look at the data during the study because we don't want you to be liable for that. Now, to me, that's a total cop-out, right? We do face a tremendous amount of moral liability, I think, for this kind of work. And it can range from, if I know that this young college student has abused alcohol tonight, what is my responsibility? I wish I had a good answer for you, and I certainly feel that sense of obligation. We have tended, and I guess total cop-out, tended to collect the data and then analyze it after the fact. But when we finally get to the point where our systems can run inline and online, I think that's going to be, one, a game changer in how we can impact interventions, but also be a real game changer in how much obligation we have to take effect right away. So the student study that I mentioned, we have 23 incidents of sexual assault during that semester that recorded in our study. We don't have enough information to do much with it. Most of those were not reported to the campus authorities. But knowing that something happened and knowing roughly the time when something happened, there's an opportunity to intervene. Obviously, we should be doing something.
Thank you.
Yeah.
I have a question about text analysis and also emoji choice and whether you're doing anything, particularly with the mental health example.
On text analysis. It's a pretty new area for me. I don't have any background with natural language processing at all. So we've mainly been looking at just clicks. We now have this really great data resource, and we did not collect any social network information, social posting information from the first time we ran the study. We are now collecting it from a number of social media sites for the second study. So we're collecting it in the hopes that I can find a collaborator who would be willing to help me understand that, but it's certainly beyond my expertise. I do think it's a huge, rich resource, though.
Hi, it's a really nice talk. I'm just wondering, like, across all the studies you've done, like, there's different kind of behaviors that you're doing, right? So I'm just wondering if there's any predictors that you're already collecting data, like those are the predictors that always pop up that actually, predicts the behavior.
That's an excellent question. So I have a really great colleague at Northwestern University, David Moore, who's a clinical psychologist. And he's the one that got me onto this particular feature of, he calls it normalized entropy, normalized location entropy. And it's just this measure of how much time you spend in various locations and what are the common locations you spend time in. That feature seems to be showing up over, now that we retrospectively have applied it to our data sets, seems to be showing up in a lot of our data. That's the only one I know of, though, that seems to be really valuable. We're still looking, and that makes sense. There's lots of studies that have shown that the fewer places, if you are someone who is becoming depressed, you'll spend time in fewer places, right? And so it makes sense that it's tied to mental health. If you're spending time in fewer places, it probably makes sense it's tied to physical health, right? So it makes sense for a lot of these things. Certainly probably has no impact on driving behavior. So we are looking for these universal features, but it's really just the beginning. So I don't have much to say other than I think it's a really important question, and I hope we can find those, because that would be a really valuable contribution to the community.
Thanks.
All right, great. Well, let's thank our speaker one more time for the fantastic talk. And thanks all for attending, and we'll see you again in a couple weeks. Thanks.